I'll share my screen. The first problem, we'll start with the second problem first, because that's easiest, and you'll get an idea like how to solve the first problem. Mm. So the problem says that we are given an integer c. Let d be the smallest integer such that 2 to the power d is exactly greater than 3. Consider all pairs of non-negative integers a comma b such that a comma b is less than 2 to the power d. Success and a or b is equal to c. So basically, what they're saying is, I'll use this one too. Suppose you have a number 3, and let's consider it for a while as 7. So the binary representation of 7 is 1, 1, 1. So we have to make two numbers, a comma b, such that it has the same number of bits as c. Like, okay, if c has three bits, then a will also have 3 bits. Like, so 1, 1, 1, this is c, and we need to have a such that there are 3 empty slots for A, and B such that there are 3 empty slots for B. Okay, and A or B should be equal to C. A or B should be equal to C. So before moving ahead, we need to know some few things. So basically, if the ones or one is zero, right? We all know this fact, and zeros or one is one, and ones or zero is one. So we will use this idea and try to solve this problem. What happens is, like, suppose we have a number 101, and we are trying to make a number, two numbers, right? A comma B. So uh, what we will do is, mm, and what has to be and there was another condition that A dot B, A dot B should be maximum. This is another condition. So since when we take two numbers, A dot B is maximum, the difference between them should not be that very much. The difference between them should be minimized. So then only we can get the maximum product. Absolute difference between A minus B should be less, minimized. Then only the product of the two numbers will be maximized. This is also another mathematical fact. And we will be using these two facts and try to write a solution for this. Suppose this is our current C, and suppose we have three bits here, zero, this. So since we have zero here, we will have one, one, and these two bits will be set because ones or one is equal to zero. We know this. So that's why these two bits are set here. So what we will do is we will give the maximum bit to A. Suppose the maximum set bit will go to one, and it will go to zero, and all the rest of the bits which are there, we will give that to B. So this way, the difference between A and B will be minimized, and their product will also be maximized, and A's or B will also be equal to C. Okay. So if so, the that was a very small observation, like giving the maximum bit to A, max bit to A. Bit to A. Suppose like suppose we have like 4 bits, and we are giving the first bit to A. So the first this thing will be 8, and suppose we are giving all the rest of the bits to B, and this thing will be 7. So the absolute difference between 8 and 7 is 1. This is like the minimum difference that we can gain. It's so this We are using this fact, and that's how we solve this problem also. So let me share my code. Mm, mhm. So first I'm declaring three variables, a comma b comma c, and since c is given, I'm taking input of c. And initially a is 0 and b is 0. What this bit says, we are finding the most significant bit of C. Most significant bit, do you guys know what most significant bit is? I'll explain that what most significant bit means. Suppose 1011 and 0000. So in this number, the most significant bit is this one. And if we have another bit set here, then the most significant bit will be this one. So most that is the most significant bit. So that's how we declare a most significant bit. And initially, as I told you, the most significant bit will go to the A. And also another fact is if the bit is set, then we can, if the bit is not set, so meaning see it is 0 here, so we can give it to both A and B. Otherwise, we will give it to just B. Okay. So that's how we maximize the product, and at the same time, A's or B is also equal to C. Cool. I'll share the submission link here. Do you guys have any doubt in that problem? And we will be going to the first problem, today's first problem. Just a minute, guys. This is another problem. If JJ has three integers n a comma b, where a comma b should be less than or equal to 2, and meaning that it should have the most significant bit should be n minus 1. So the value of a's or x and into b's or x is maximum. So explain what I mean. So wait, I'll explain that again. So what I'm doing is, since I explained that we have to minimize the absolute difference between A and B, then only the product between them will be maximized. And I also showed you guys, like, since we are giving the most significant bit to A, all of the rest of the bits should go to B, in which the set C is having a set bit. And if the bit is not set, then both A and B can have. Since we know that ones or one equal to 0, that's why both will have that set. Mhm. Okay. So I'm moving to the next question. Uh, so this was, I explained you the problem, and what we have to do is, uh, we have n, we have n, and a comma b. What we have to do is we have to find a's, or we have to maximize a's or x dot b's or x. Okay, and we have to find an x such that x is greater than or equal to 0 and x is less than 2 to the power n. So I already explained you guys, whenever we want a multiple of a comma b to be maximized, the uh, absolute difference between b minus a should be minimized. Okay, so this is the basic condition that we have to follow. Which means a dot b, if the both this, I explained to this previous also, like, if we want to maximize a dot b, then the difference between them should be minimum. So again, what we have is, we will just mm, iterate, like, suppose these are the two numbers, 1011, 1010. Okay, since another thing we have to note, what we have to note is, Sudhir, can you please stop that? Since you know that ones or one equal to zero and ones or zero equal to one and zeros or one equal to one. These are the basic things we have to remember whenever we are solving problems related to job. So we have to find out an x. So what we can do is uh, since both of the things here having are zero, we can have the x, the place here should be, we can easily give it to one. So we will maintain two variables. One variable will be, suppose let's denote as a, which will be equal to a or x that we are finding. And we will also maintain another variable b, which is equal to b or x. And we will find out the x in such a way that the absolute difference between a comma b is minimized. So that's our goal for now. So it will be so it will whenever we have same bits, we can set the x can be same as that particular. Suppose a is also having zero and b is also having zero, then we can set for that particular bit x as one. Since we want to maximize the numbers, right? And suppose a is having one and b is having one, and we have to set the x as zero because if suppose ones or zero, then it's one. That's why if a is having one, b is having one. If we set x as one, suppose we are setting x as one, so ones or one will be zero, right? Will be zero. That's why we do not want to set. So that's why these conditions, like whenever a and b both are zero, then x will be one, and whenever both a and b are one, then x will be zero. Okay, and these are the easy conditions. Like anyone can fill this condition. Now the hard conditions begin. Like how are we going to handle the case when a and b are not, when the bits of a and b are not equal? Suppose the bit of a is one and bit of b is one, or the case of bit of a is zero and bit of b is one. So we will handle it this way. Since we know another condition that we define a small a equals large a dot xor x and small b equals large b xor x. We want to minimize the difference between them. So suppose whenever the bits are not equal, we will check which number is larger. Suppose if b is larger than a, suppose if b is larger than a, what we will do is we will add the particular bit to a so that the difference becomes minimized between them. And same case, whenever a is greater than b, what we do is we try to add the number into b. B here means this one. So that way we can manipulate the x. So I'll show my code. That way you can understand better. And if you're not having any problem, I'll suggest you write it on a paper and write with a paper and pen. Then you will have a better idea. So where is my code? I did not Let me first submit my thing. I did not submit it. That's giving me wrong answer. Just a minute, just a minute. People where the position got decided. So what we have, so the first, this condition is right. So we will discuss this condition first. So what is happening here is, since both the bits of A and B are same, we were having the vice versa of that bit in temp A and temp B. Okay, meaning both of them get that. We have to do it this way. No, no, temp and temp should be zero only. Because we are initializing them with zero, right? We don't know what the values are. 9201. No, I'm not giving them zero or something. Oh, temp and temp should get one actually. Because why that? Because either, okay. Mhm. Okay, so let me just why is it- can anyone see what is going wrong? Like, maybe I equal zero, something, something. So, yeah, that's what I'm thinking. How come X equals with X is becoming 21? Just a minute. Should I send this solution sometime later? Like, not able to actually see the bug in this. Yeah, I'll send this submission link. Yes, I'll end this meeting and I'll send the submission link. There is some minor changes here. Mm, Let me try for 5 minutes and it will be Let's do it in a clean way.
Means